Good evening students, my name is Prashant Pachangre and today we are going to learn the topic Ohm's law. So let's begin. So the Ohm's law is invented by the scientist George Simon Ohm, and he has done one experiment with the two different batteries. Suppose we have one battery having the potential difference 9 volt, and this battery is connected to the electric bulb. This is the electric bulb, and another battery is connected to the another electric bulb having a different potential. Let us consider the 6 volt, and this battery again connected with the electric bulb. And what is the observation done by the scientist George Simon Ohm? He observed that the bulb with the higher potential will glows with higher brightness, as compared to the bulb which is connected to the lower potential, that is a 6 volt here in this case. So what he observed that with the higher potential, it means that higher brightness, it means that the more current must be passing through the given wire. For the lower potential, the current must be less as compared to the higher potential, and therefore the less brightness he observed for the given electric bulb. The Ohms observed that the voltage or the potential difference is proportional to the electric current. More the potential difference, more will be the current. He observed that the potential difference is depends on the electric current in the circuit. So from that he has given the law: if the physical conditions are constant like temperature and pressure, the potential difference is proportional to the electric current. So here we have written V is proportional to I. If we remove the proportionality sign, we can write V is equal to some constant R multiplied by the I. So we can also write this V is equal to I into R. This R is called as the resistance. What is the resistance? This resistance is basically opposing the flow of electron. From this formula we can write R is equal to V divided by I. So the resistance can be calculated by taking the ratio of potential difference and electric current passing through the circuit. Now resistance is basically opposing flow of electrons. Now we have to calculate what is the unit of resistance. So to honor the scientist George Simon Ohm, we have given, or scientists have given the unit of resistance as a ohm, and the symbol is omega. So we can say the SI unit of the resistance is ohm. SI unit of resistance is ohm. Again with formula R is equal to V divided by I, we can also tell the another unit of the resistance. From the formula, V is the potential difference, and potential difference is measured in volt, isn't it? So volt, and current is measured in ampere, therefore volt per ampere, that is also another unit for the measurement of the resistance. So volt per ampere or ohm, these are the two units for the measurement of the resistance. And resistance is the basically opposing flow of electron in the circuit, or it can be calculated by taking the ratio of the voltage and current in the circuit. Okay, so this he observed that for the metallic conductor or the different material like semiconductor, the graph is basically different. So for metallic conductor, he observed that the graph y-axis versus x-axis, if we take the along the y-axis electric current, it is in ampere, and the voltage along the y-axis, he observed that the graph is a straight line passing through the origin. So what is the meaning of this graph? The I is proportional to V, or V is proportional to the I. So V is equal to IR. This basically metallic conductor or metal basically follows the Ohm's law. It means that if the voltage increases, current also increases, or we can say if the voltage increases, current also increases. If voltage decreases, current also decreases. But this is not for the all materials. If you take another material like a semiconductor, the semiconductor doesn't follow the Ohm's law. What does it mean? It means that if we have the y-axis electric current in ampere and resistance or current in milliampere and voltage along the x-axis, he found that the graph is basically current versus I is showing like this. It means that initially there is no change in or very less change in current with increasing voltage, but after some time with increasing voltage current suddenly rises. It means that the voltage and current are not linearly proportional to the one another for the semiconductor material, like we can say silicon or germanium. Semiconductor, this graph basically Ohm's law is not followed. So this law is basically applied for the certain materials, certain metals like electric iron, copper, silver, like this metallic conductor basically obeys the Ohm's law. Next important thing is that he observed that if we have to measure the resistance of the given wire, that is basically with the values of the voltage and current, by taking that ratio, corresponding ratio, we can measure. But resistance is can be measured, but it is not depends on the voltage and current. Resistance is depends on the length of the wire. Suppose we have a wire, as we know the wire has a cylindrical shape and the wire having the length L. So the resistance present in this wire is proportional to the length of the wire. More the length, more will be the resistance. Now next one, we have to observe about the thickness of the wire. So thickness of the wire is basically depends on the radius of this wire. Small radius, cross sectional area. So cross sectional area of the given surface, you can see the front side of the wire. It is the circular shape, and circular shape having area pi r square. So r is the radius. If the more the value of the r is the radius. If it is a more, then area will be more. And he observed that the resistance is inversely proportional to the cross sectional area. It means that more the thick wire, less will be the resistance. More the thin wire, it means that small r will be there, small radius will be there, and smaller the radius will have the smaller cross sectional area, and smaller the cross sectional area, more will be the resistance. So he observed that resistance is depends on the length and cross sectional area. How it depends? More the length, more will be the resistance, and less the cross sectional area, more will be the resistance. So it means that resistance is proportional to the length and inversely proportional to the cross sectional area. So we can write the formula R is equal to, again here is the proportional sign. If we remove the proportional sign, we will write some constant. Here we have written rho multiplied by L divided by A. Now we can say the resistance depends on length and cross sectional area. Again there is some constant. This is a rho, this is a rho, and this is called as the resistivity of the material. Resistivity of the material, and this resistivity is the basically property of the material which opposes the flow of electron. Resistivity is the property of the material opposes the flow of electron, and this resistivity depends on the material, not on the length, cross sectional area, and resistance present in the wire. Again the resistivity can be calculated by taking the formula. Area is here divided, it will multiply, length multiply, it will divide. So rho is equal to RA divided by L. So resistivity is equal to R times A divided by L. So resistivity can be calculated by knowing the value of resistance, cross sectional area, and length of the wire. So resistivity is the basically property of the material to opposes the flow of electrons. Now we have the different materials: copper, aluminum, zinc. So for metal the resistivity is very less, therefore the more current is passing through it if we connect it with the battery. But for the semiconductor and for the insulating material, the resistivity is very high, therefore very less, extremely less current is passing through the insulating material because of the high value of the resistivity. Now we have to find the SI unit of the resistivity. So SI unit can be measured or can be calculated by the formula. Here the O is equal to RA divided by L. So resistance is measured in ohm, area is measured in square meter, length is measured in meter. So meter get cancelled. The SI unit of the resistivity will become ohm into meter. So ohm meter is the SI unit of the resistivity, and more the resistivity, less is the conductivity. So therefore the conductivity is a reciprocal of the resistivity. So conductivity of the given material is denoted by the sigma, and this is the conductivity denoted by the sigma is the Greek symbol. It is equal to reciprocal of the resistivity. More the conductivity, less will the resistivity. Less the resistivity, more it will be the conductivity. So they are reciprocal to one another. Okay. Next important topic is resistive is the resistances in series and parallel combination. Suppose we have an electric circuit, and in this circuit we have connected three resistors with different values of resistances, and with these three resistors are connected with the battery with the potential V. What we will find that the current is passing through the given wire. The current passing through the first wire I1, second I2, and third I3. So if they are connected in parallel, the different current may be passing through the different wire, depends on the resistance in the wire. So we can see that we have to find the total electric current passing through the given wire. So we can see that the different currents are there. So I1 we can write V into V divided by R. So here these three resistors are connected in parallel combination. These three resistors will have the same potential difference. So I1 is equal to V divided by R1, and then I2 is equal to what it is? V divided by R2. Then on third one is I3 is equal to V divided by R3. So where we have to find the total current? How can we find I1 plus I2 plus I3? So therefore the total current is I1 plus I2 plus I3. So we will put the value of I1, I2, I3 from this expression, and we can write the I is equal to V divided by R, and as the three resistors are connected in the parallel combination, we can write Rp is equal to I1 की value कितनी है? V divided by R1. Then second I2 is V divided by R2. I3 it is V divided by R3. Then we take the V common, V divided by Rp. We take common 1 by R1 plus 1 by R2 plus 1 by R3. Here V and V get cancelled. We get the formula 1 upon Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If such a n number of resistors are connected in the parallel combination, then we can write the general formula to get the equivalent resistance of the given resistors if they are connected in the parallel combination. So 1 upon Rp, that is equal to 1 upon R1 plus 1 upon R2 and so on, and we can write 1 divided by Rn. So this is the general formula for the measurement of the resistances which are connected in parallel combination. 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 and so on plus 1 upon Rn. So here we can observe that if we have the different type of the resistors, then we can easily use the formula and we can find the equivalent resistance present in the circuit. So we have connected these two resistors with a battery having the suppose 10 volt potential difference, and with key we have connected. Suppose we have to find what is the current passing through the circuit, then we can measure using the formula V is equal to IR. Suppose we consider the resistance present in the first wire. It is given as a 5 ohm and second having the 15 ohm. Then we have a question, how much is the current passing through the circuit? So as we know the formula of the resistance, when they are resistors are connected in parallel combination, we have formula 1 upon Rp is equal to 1 divided by R1 plus 1 divided by R2. So we can directly write this formula, Rp is equal to R1 times R2 divided by R1 plus R2. Here we just have to put the values. 1 upon Rp is equal to value of R1, it is a 5 multiplied by 15 divided by 5 plus 15. So what is the answer? 5 into 15 we will write as it is, and we can take the addition of the 5 and 15, it is become 20. So 5 4s are 20, then 15 divided by 4, that is the value of the basically resistance present in the wire. This will be called as the equivalent resistance or total resistance present in the given wire. So now we have to calculate the electric current. So I is equal to voltage divided by total resistance or equivalent resistance divided by Rp. So I is equal to the potential difference of the battery is 10 volt. So we just put the value of 10 volt divided by the value of Rp, it is 15 divided by 4. So we just put here value 15 by 4. Now I is equal to this 4 will come to the numerator, 10 into 4 divided by 15. Now we divide it by the 5 to the 10 and 5 is a 15. Then I is equal to 2 into 4, that is a 8 divided by 3, that is in ampere, and this is the current present in the circuit. Now we observe that these two resistors are connected in parallel combination. It must have the same value of the potential difference, but different current will pass through the given section. Okay, from here section we can say this current is I1 and this is the I2. Okay, so different current will be there. So if we have to find the electric current, we can also find out the current that is I1 and I2. So how can we find that? Is simply we can find this current is equal to I1, that is equal to V divided by R1. So as we know the potential difference across the I1 and I2 is same. So how much it is there? 10 volt, because the battery voltage is 10 volt. We just have to put the value 10 volt divided by R1, that is equal to 5. So 10 by 5, that is equal to 2 ampere. Okay, that is equal to 2 ampere. Now let us calculate I2. So I2 is equal to what? Voltage divided by R2. Voltage is given 10 volt. The value of R2 is 15. So we just divide by 15. 5 2s are 10 and 5 3s are 15. So 2 by 3, that is the current passing through the this section I2. Okay, so 2 divided by 3 ampere, this will be the value of I2. So in this way we can basically calculate the current through the different branches. As we know that the current will be maybe different or maybe same, depends on the value of the resistance. If the resistors are the same current will pass through both the branches. If the resistance will be different, the current will be different. Now next thing we have to learn about the resistances if they are created in series combination. So here we can take that R1, R2 and R3. These are the three resistances which are connected in the series combination. So here we have one battery, and if we are passing current I through them, so we can consider the resistance R1, R2 and R3. Now we know very well that the current is passing through all the three resistances. That must be the same, because the same current is passing through the R1, R2 and R3. Therefore the current through the R1, R2, R3 must be same. So here what is the difference? Their difference will be the potential difference. The potential difference will be V1 across the R1. If the potential difference across the R2 is V2, and if the potential difference across R3 is V3. So the total potential difference is V, and that is equal to V1 plus V2 plus V3. Now here in this case the current passing through the given wire is same, while the potential difference is different. So we put the value of the Ohm's law. V is equal to IR, and is equal to, instead of V1 we can write I1 I as it is R1 plus I times R2 plus I times R3. We can take the I common in this case, and we will get R1 plus R2 plus R3. Here I get cancelled, and the total resistance in the circuit we will get Rs is equal to R1 plus R2 plus R3. If we have n number of resistors, and if they are created in the series combination, then n number of resistances, or from the n number of resistances, the total resistance will be Rs is equal to R1 plus R2 plus RL. So we have to simply add the value of resistances to get the equivalent resistance or total resistance present in the circuit. So Rs is equal to R1 plus R2 plus R3. So simply we have to take the addition. So we can take one example. If we have one resistor, another resistor, this is two resistors and with battery voltage about 20 volt, and the resistance is 5 ohm and another one is 15 ohm. Then what is the value of the electric current passing through the given circuit? So as we have the formula, total resistance for the series combination R1 plus R2, we take simply addition, that 5 plus 15, and that is equal to 20 ohm. So we can see that the resistance is 20 ohm, battery voltage is 20 volt, So easily we can find the current, that is equal to I is equal to V divided by R. Voltage is 20, resistance is 20, 20, 20 get cancelled, current is equal to 1 ampere. So current we will get 1 ampere. In this way we can easily calculate the amount of current passing through the given circuit. Okay. Next is the Joule's law of heating. So what is Joule's law of heating? Joule's law of heating says that the given wire will get heat. It will heated. It depends on the amount of current passing through the given wire. It also depends on the resistance present in the given wire. So he said that the heat H is proportional to the I square RT, where I is the amount of current. More the current, more will be the heat. Okay. Second, he says that he is proportional to the resistance. If the more resistance present in the given wire, more heat it will generate. So you can see that the wire is present in the heater having the high resistance because it has a high resistivity. As we know, R is equal to rho times L divided by A, or rho is equal to RA divided by L. It means that R is equal to rho times L divided by A. So resistance is depends on the length and cross sectional area. If the wire having the more length and very small radius, that is a very thin wire is there, then it will have the more resistance. So the heat is present in the wire, it depends on the resistance, and resistance depends on the length and cross sectional area. That's why the wire which are used in heater is very thin, because it will have the less cross sectional area and the wire length is more. So the heat is present in the basically wire depends on the resistance. Another third parameter is the heat is depends on the time for which the electric current is passing through the given wire. So combined we can say H is equal to I square RT. Here some constant we will get and its value is 1. Therefore we directly write H is equal to I square RT. And this is Joule's law of heating. Okay, Joule's law of heating says that the amount of heat generated is directly proportional to the square of the current and directly proportional to the resistance passing through the resistance present in the wire. And the third one is the time for which the electric current is passing through the given circuit or given wire. So H is equal to I square RT. Next is the electric power. What is electric power? Electric power is unit by P, and electric power is basically multiplication of voltage and current. Power is basically multiplication of voltage and current. So power is equal to voltage into current. So therefore we can write the SI unit of the power. SI unit of power is basically volt ampere. But to one of the scientists, watt, we have given the unit of the power, that is a watt. The unit of power is watt, simply denoted by W. So power, SI unit of the power is watt. Now next thing is that another form, different forms of the electric power. So we know the Ohm's law. What is Ohm's law? V is equal to IR. So we can put the value of V, that is IR here, and I as it is. So what we will get? P is equal to I into I square, and this R as it is. So another formula, another form of the electric power is P is equal to I square R. Now next form we can write here, the power is equal to VI, and again we use the Ohm's law, that is V is equal to IR. So we can write instead of I, V divided by R. So power is equal to, V will be as it is, and instead of I, V divided by R. So V divided by R, V will get multiplied, so V square divided by R. So this is another form of the electric power. So power is I square R, it is V square by R, and power is equal to voltage multiplied by current. So okay, so SI unit of the power is watt, and higher unit will be kilowatt, megawatt. Okay, megawatt, 1 kilowatt is 10 raised to power 3 watt, megawatt 10 raised to power 6 watt, isn't it? And the another unit is basically commercial unit is there, that also we have to see. And another one is the 1 HP is the horsepower, that is 746 watt. Okay, so another unit we have to see. Okay, so next one is the electricity bill. So we know very well that the our electricity bill is measured with unit, and that unit is given it is basically kilowatt hour. What is the kilowatt hour? And that is unit of energy. Unit of energy. Kilowatt hour is the unit of energy. It is a commercial unit of energy. What it is there? Commercial unit of energy. So if question is asking what is the commercial unit of energy, that is kilowatt hour. Now we know very well the unit of energy, it is a joule. Unit of energy is joule. Then why the unit of kilowatt hour, and how can we convert kilowatt hour into joule? So simply we know kilowatt hour can be converted into the joule. Kilowatt is basically 10 to the power 3 watt multiplied by hour. How can we convert hour into second? So 1 hour means 60 minutes and 1 minute means 60 seconds. So we can directly convert 60 into 60, 3600 into 10 to the power 3 watt second. So in watt second we can simply write the joule. So we convert decimal point, shifting decimal point, 3.6 into 10 to the power 3 into 10 to the power 3 joule second. Okay, it is in joule, sorry. Okay, so 3.6 into 10 to the power 3 plus 3 10 to the power 6 joule, and that will be the conversion of the kilowatt hour into the joule. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. This is important conversion between the commercial unit, that is kilowatt hour, and joule. So kilowatt hour is the unit of energy. It's commercial unit of the energy. Next thing is that we have different appliances, and if we connect in a parallel combination, as we know there are different electric appliances we are using, like electric tube, fan, and refrigerator. So for the different time we are basically using these appliances, and we have to calculate the total amount of energy utilizes for 1 month. So how can we find out the electricity bill? So it's a very simple formula. We can say that suppose we have the different appliances, like suppose we are using the tube lights, and this tube light is basically 20 watts, and we are using this tube light for the purpose for the basically 8 hours in a day. Then what is the electricity bill for the total month? So another we can say, if we have a fan, it is there, and fan we are is a basically 100 watt fan is there, and we are using fan for the again 8 hours. So what is the electricity bill that we have to calculate? Okay, so for these two appliances, suppose we have to measure the calculate the electricity bill, then simply we can calculate suppose we have no power is measured in kilowatt hour. So for first for tube light total power, total energy in kilowatt hour we can measure. First we have to convert the power kilowatt into the power watt into kilowatt hour. So how can we convert 20 into 10 to the power minus 3 kilowatt? Or how much hour it is there? 8 hours. So this will convert in kilowatt hour. Okay, this will convert in kilowatt hour. So we can simply multiply this 160 into 10 to the power minus 3 kilowatt hour. Okay, kilowatt, and this is hour, and this will convert in kilowatt hour. This is for the single days. How much it is? 0.16 kilowatt hour. Now tube light we are using. Second we are using the fan. Fan we are using. So fan how much hour? 8 hours, and we have to convert in kilowatt hour. So 100 into 10 to the power minus 3 kilowatt multiplied by 8 hours. So it will convert 800 into 10 to the power minus 3 kilowatt hour. This is for the 1 day. Okay, so how much energy? 0.8 kilowatt hour for the single day. So we have to calculate electricity bill. If the rate for 1 kilowatt hour is 10 rupees, then what is electricity bill? So total energy used for a month. We have to calculate. So how can we calculate total energy? This is for 1 day, 0.16 plus 0.8. This is for the single day, and if you consider 30 days, we will multiply with 30. So we can simply do the addition. What will be the addition? This addition is basically 6 as it is, and 0.96 multiplied by 30. So this will be 9.6 into 3. So this is basically in kilowatt hour, and we have to measure this electricity bill for the 1 month, and the rate is basically 10 rupees, rs 10 rupees for the 1 kilowatt hour, means 1 unit, we call as 1 unit. So we can basically measure the total amount, total bill for 1 month. How can we measure? So simply the amount of energy used, how much is 9.6 into 10 raised to power 3, 10 raised to power 3, how much, sorry, 9.6 10 raised to power 3 multiply with the amount 10. So 96 into 3. So multiplication 8, 288 rupees. Okay. So amount total electricity will be 288 rupees for the 30 days. Okay, for 1 month. In this way we can basically measure the electricity bill with the different appliances for the different durations. Okay, hopefully you have understood all the things, and this fast revision series. Okay, we'll stop here and we'll see in next video. Thank you.